While there are many reasons our customers choose StreamSets, some of the most important ones are a single experience with many patterns available, our schemaless engine and the fact that we are drift aware, our APIs and automation capabilities, and our ability to enable data engineers to then enable the enterprise. What we mean by a single experience, many patterns, is that StreamSets is able to accomplish a wide variety of data movement patterns and architectures leveraging a single common platform. Capabilities have been added in organically rather than via acquisition of other technologies and cobbled together. Many of the modes, types, locales, and engine deployment patterns are shown here, and all benefit from the common experiences and capabilities listed. Let's look at some examples. First up is a pipeline from the data engineer use case demo. This is a batch bulk ingest of an on-premise database into Snowflake. The StreamSets engine was deployed as a tarball on an on-premise machine. From there, we can do change data capture to the cloud, so this is very similar, except that it moves into more of a streaming mode rather than a batch mode for ingest. We even have modes where our engines can run directly on an on-premise Hadoop cluster, and in this case, migrate data from that Hadoop cluster over into Azure Data Lake. Here's a cloud-to-cloud use case, migrating data from BigQuery to Snowflake. The StreamSets engine was running as a Docker container inside an EC2 instance in Amazon. An IoT example with a pipeline listening on a TCP socket for device data, which is then enriched and pushed to Kinesis and Elastic. The StreamSets engine is running in an EKS cluster on Amazon. This is an example of a batch ETL pipeline with multiple origins, joins, aggregations, and so forth. When executed, it is fully pushed down into a Databricks Spark cluster. Similarly, this is our capability of reading, processing, and writing data within Snowflake. Execution is fully pushed down to the Snowflake cluster via the Snowpark API in an ELT fashion. And we can do reverse ETL, in this case taking data that was produced in a BigQuery via some analytics, doing some lookups in Salesforce to match what we're pulling out with a specific account, and then writing that analytic result data back into an account record inside Salesforce. StreamSets can expose pipelines as REST services, effectively turning data access and manipulation into a microservice. This example, REST enables some specific CRUD operations on a dataset. We can assist in AI and ML efforts by leveraging a pipeline which uses a custom Scala processor to feed data to a model which was executed on an EMR cluster. We can then take a functional model and apply it to new data and use the model results to route data to different places. Notice in all of those pipelines we were using the same design canvas, look and feel, and availability of features. This makes adopting StreamSets much easier and helps data engineers accomplish the wide variety of patterns and architectures shown. Conceived originally as a way to tame the deluge of formats and structure ingested in the early Hadoop ecosystem, StreamSets was built from the ground up as a schemaless or schema-on-read engine. Records can have independent structures, even from the same origin, without guaranteed ill effects. This makes StreamSets highly resilient to change, more robust, and reduces or eliminates break-fix cycles engineers would normally face when unexpected change occurs. From our prior demonstration, here's an example file on S3 that has 3 records of widely varying format. As you can see, we can preview the pipeline just fine. StreamSets also operates on a principle of minimal specification. This means that I don't have to tightly wire an entire schema into the pipeline. Instead, I only use what I need to get the job done. Here I'll insert an expression and we will modify the user ID and multiply it by 10. Running preview again, we can see that the modification worked, and a user ID was even inserted with a value of 0 automatically on the 3rd record. If we have logic that absolutely requires a field exists, we can set on any processor that a field is required. Any record missing that field will be sent to the error path instead, which we can configure to route to various files or queues for later remediation. This capability of StreamSets is what provides for ingesting entire databases, lists of varying files in a directory, and doing change data capture across many tables in a single pipeline. In addition, we can alter destinations to accommodate new data elements in the incoming data, which is what we call drift synchronization. One of the real strengths of StreamSets is its robust API and SDK layers. Virtually everything you can do through the UI, you can also do via a REST API call. We also have a Python SDK, which allows you to automate the creation and manipulation of pipelines, jobs, and other objects within StreamSets, allowing for automated testing and generation of pipelines from code. In this example, I'll show how we can use that Python SDK to modify and upgrade a pipeline and its dependent job. Here we're looking at a topology, which is a visual representation of multiple pipelines working together to produce an end result. In this one, data is being read and written to Kafka before being written to multiple destinations. If we look at the Kafka streaming pipeline in the middle, we can see that it is reading from a single topic called weather raw. And we have external factors that may dictate that these topic names change. So one way to handle it would be to build things manually or go change it manually, but the other is to use the Python SDK and change it programmatically. Here's a Python script using the Control Hub package from the SDK, and here we are setting up a list of 3 topics to consume. When I run this, it is modifying the pipeline, checking in a new version, and telling the platform to upgrade the running job. Now going back to our jobs list, we can see this splat indicating that the underlying pipeline has a new version, and you can also see the platform automatically deactivating the job to upgrade it, which we see here, and then restarting the job. Hopping back into the monitor screen on the job and going into the configuration, we can see that it is now running with the 3 topics, matching what we set via the SDK. Finally, we have engine framework APIs, which allow you to create custom native origins, processors, and destinations when needed. And the final category is how we enable data engineers to enable the enterprise. The first way we do this is via extensive customizability with scripting origins and processors throughout the platform. While we have a lot of great capability out of the box, we don't limit the users to what we have thought of. Here is a quick example pipeline which shows using embedded code as both an origin to produce records, as well as processors in different languages, Groovy, Jython, and JavaScript, to manipulate records in flight. For each component, there is a script area to access and manipulate records flowing through the pipeline. We can even use preview with them and see how each processor has modified the records. We also have SQL processors for Snowflake and Spark pipelines, as well as Scala and PySpark processors for Spark-based pipelines. The second way we enable the enterprise is through reusability and simplification. We abstract connections, allowing connection parameters and credentials to be secured. All objects have full read-write security, so they are only exposed to those who need them. With connections, a user simply needs to choose an appropriate connection from a drop-down rather than enter everything in themselves. Next, we have pipeline parameters. This allows configurations from multiple parts of the pipeline to be centralized in one place, as well as allowing job definitions to alter those values, giving flexibility within a single pipeline definition. Fragments allow encapsulation and reuse of logic across pipelines and developers. A change to a fragment will change it in all pipelines once they are upgraded to the changed version. Finally, templates combine all of these into a pipeline example, which can act as a quick start for a developer following a common pattern within the enterprise. Any pipeline can be a template by simply adding the template's label to it. Once that is done, when a user creates a new pipeline and chooses to start from a sample, they can choose user samples and pick any template which has been provided. Once in the canvas, they have a working example which can be modified or simply configured as required. Finally, with our APIs, many customers have created their own specific front ends for users to work with data, which then generates StreamSets pipelines and jobs in the background. We believe these capabilities in these core concepts Give StreamSets a unique value and position in the market.